Welcome to Marina's Point. A 500 watt 100 volt bulb is connected across 250 volt and frequency is given 50 Hz. Find the value of capacitor which is required to connect in series. Okay, question is given. So what are the data given? Power of the bulb is given 500 watt. Rated voltage how much? 100 volt. Supply voltage given 250. Frequency is given 50 Hz. Now, the bulb and the capacitor are connected in series. So need to we must need to find capacitance required so that bulb receive its rated voltage 100 volt when connected to 250 volt and 50 hertz supply. Okay. Now we are going to calculate first find the resistance of the bulb. As we know that power is equal to V square divided by R. So using this formula, we can calculate the resistance. Okay. So we will get resistance value 20 ohm. Okay. Next, relation between voltage in a series RLC circuit. Because the bulb and the capacitor are series, it is given, condition is given, the current through both the same. Yes. If it is in series, current will be same. If it is in parallel, potential difference will be same. The voltage across the capacitor lags the current by 90 degree, while it is given capacitance that's why this is condition. Capacitor, it is a capacitor, that's why voltage across the capacitor lags by the current 90 degree, while that across the resistor is in phase with the current. So net voltage is equal to under root the resistance voltage square and capacitance voltage square under root. This is net resultant voltage. Mainly it is written in vector quantity. If any quantity A x plus iy, then mod A is equal to under root x square plus y square. Okay. Same things here. One in 90 degree lags and one is in with phase. So 90 degree lags by the current. So if we take resistance, so it is in x direction and it is in y direction. That's why it's like VR plus Z VC. Okay. That's why this formula come under root VR square plus VC square. Okay. So we will get main supply voltage is equal to, using this formula, and using this formula we can find capacitive potential. So VC we will get by solving this. Okay. Next, find the circuit current. Circuit current I is equal to VR by R, 100 divided by 20. 5 ampere will be your answer. Next, capacitive reactance. So potential difference across capacitance divided by current. 229 divided by 5, we will get answer capacitive reactance. Next, calculate the capacitance. Formula for capacitance we know Xc is equal to 1y divided by 2 pi Fc. Okay. Main formula is 1 omega c and omega is replaced by 2 pi frequency. So it will come capacitance value. Thank you.